Well, to make 2,4,5-T, you start with tetrachlorobenzene, a benzene ring with 4 chlorine atoms attached to it. These chlorine atoms are very electronegative, so they want to steal electrons from nearby atoms. Luckily for them, the 6 carbons in the benzene ring are all sharing their electrons in these fuzzy donut-shaped clouds around the ring. That's what this circle in the diagram is meant to represent. The chlorine atoms pull on this electron cloud, bringing it closer to themselves, and as a result, the carbons in the benzene ring become slightly positively charged, and the chlorines slightly negatively charged. Now, if you heat up tetrachlorobenzene with sodium hydroxide, one of the negative hydroxide ions will want to bind to one of the slightly positively charged carbons in the benzene ring. And to do that, it forces out the chlorine atom, taking its place. This creates trichlorophenol, or TCP, a key ingredient in making the herbicide. From here, if you keep the reaction at 170 degrees Celsius, you can add a series of chemicals to grow out this oxygen tail into an acid, giving you 2,4,5-T.
But Schultz wasn't satisfied with this. Maybe the conditions aren't perfect. Maybe there is something in this process, some secret reaction that is contaminating the whole chemical supply.
Ideally, the industrial process of transforming tetrachlorobenzene into 2,4,5-T should happen at 170 degrees Celsius, but if the temperature gets any higher, even just a few degrees higher, there is suddenly enough energy in the system for 2 molecules of TCP to fuse together. This creates a molecule commonly known as dioxin. It forms only in trace amounts, so you might expect to end up with roughly 1 or 2 molecules of dioxin for every 100,000 molecules of 2,4,5-T. It seemed too small to be a problem. Nevertheless, Schultz decided to test it. He took some TCP, this time contaminated with trace amounts of dioxin, and rubbed it into his own skin. And he got the same acne as the workers at the nitro plant.